Hello everyone, welcome to this video where we will be understanding about refraction through lenses. But before that, let us understand what do we mean by these lenses. To understand the formation of the lenses, let's start by creating a glass sphere. Once we have this glass sphere, we will slice it. And next, we will combine these sliced parts in the following manner. We'll make a clone out of it, mirror it, and then join it. In this way, we get a lens which we call as the convex lens. You can notice that this lens is thick at the middle and thin at the edges. Another way of combining these sliced parts was if we could take the clone, right, and then take another clone, mirror it, and join it like this. In this way, we get a lens which we call as the concave lens. This lens is thin at the middle and thick at the edges. As we saw, these lenses are made out of a glass sphere. That is why they are called as spherical lenses. Next, we will like to see what happens if we place a light source and then place concave or convex lens in the path of the rays of that light source. Let's first place a light source. Our light source is basically an array of lasers. Next, we place this convex lens in the path of these rays. As we see, these light rays tend to meet at a given point after refraction. Basically, they like to converge after refraction. That is why this convex lens is called as the converging lens. Next, we place this concave lens in the path of these rays and see that light rays after refraction tend to move away or diverge. That is why the concave lens is also known as a diverging lens. Now we know two things. Spherical lens is made of spherical surfaces, and number two, they refract, that is, they change the path of light rays. Therefore, a lens basically means a transparent refracting medium that is bounded by two spherical surfaces. Let's now understand some basic terms related to these lenses. First term is the center of curvature. As we saw, these lenses are a part of a sphere. Therefore, center of curvature is the center of spheres to which these surfaces actually belong to. Next, we talk about radius of curvature, which refers to the radii of spheres out of which these refracting surfaces are obtained. There may be two cases. Either both the spheres are of equal radii, which give rise to equiconvex or equiconcave lens, or the spheres can be of different radii. In this case, lenses are not equiconcave or equiconvex. The line which joins the center of curvature of these two spheres is called as the principal axis. This line can be extended infinitely in both the directions. Now consider a convex lens. If we incident a ray of light through the point O, we see that the ray of light does not change its path. This point on the principal axis of the lens is called as the optical center. This point is same for a concave lens as well. Now consider a point source be placed at f1 which lies to the left of a convex lens. The rays of light originating from f after refraction pass parallel to the principal axis. This point f1 is called as the first focal point of the convex lens. For the second case, consider light rays to be incident parallel to the principal axis. The rays of light after refraction will meet at a point which is called as f2. This is known as the second focal point. The convex lens is therefore a converging lens. We can repeat the activity with a concave lens and see that the first focal point of a concave lens is the point on principal axis where the incident rays will appear to meet such that after refraction they become parallel to the principal axis. On the other hand, the second focal point of a concave lens is point f2 on the principal axis of the lens such that rays of light incident parallel to the principal axis of the lens after refraction from the lens appear to be coming from it. In case of lenses, we usually mean the second focal point when we talk about focus. Therefore, the distance between the optical center and the second focal point is known as the focal length of the lens. Notice that a concave lens has a virtual focus because the rays actually don't meet at that point but actually appear to be coming from it or appear to meet at it. We can summarize our discussion on these lenses by the following table. This table represents the differences between a convex and a concave lens. A convex lens is thick at the middle and thin at the edges, whereas a concave lens is thick at the edges and thin at the middle. A convex lens is a converging lens, whereas a concave lens is a diverging lens. A concave lens has a virtual focus, whereas a convex lens has a real focus. We can continue our discussion on lenses in the next video, where we will learn how to construct ray diagrams and also solve some numerical problems based on the lens equation. So I'll see you in the next one. Thank you for watching.